Welcome to this one short video of application of derivatives for board exams. What I have seen in my experience of 12 years is this chapter is extremely important in board exams and has a lot of weightage to it. So in order to help you out, what I have done is I have divided this chapter into 5 problem types. I am going to systematically cover the theory behind those problem types and then tell you the exact technique to solve those problems. So without any further delay, let us start with it. So these are the 5 problem types we are going to deal with. The first problem type is nothing but rate of measurement problem. Then increasing and decreasing functions based problem, which are based on algebraic expressions. Then increasing and decreasing based problems based on geometrical questions. Similarly, for maxima and minima, we have algebraic expressions and geometrical problems. Now let us first start with the first problem type, that is nothing but rate of measurement. So if I look into this problem type, what is the underlying logic? So when you'll have to solve problem, like we'll see in this 2018 question, we will start by formulating a function. Once we have formulated a function, we are going to differentiate it. And from there, we will get nothing but rate of change. So we are going to use this algorithm to solve problems. So there are 3 simple steps in order to get to an answer. So let us see this question. The question talks about a total cost function they have given. You can see that it has been given in the form of an algebraic expression. Let us write it down. So Cx is nothing but 0.005 x cube minus 0.02 x square plus 30x plus 5000. This has been given to us. What they're saying is the marginal cost when 3 units are produced. What they're saying is we need to find the marginal cost when x is equal to 3, because x is nothing but the production of units. Now what they have also given us is basically how do we define marginal cost. So sometimes the students will look into a question and see that okay, marginal cost I don't know, but if you read the question carefully, they have given us the what is this marginal cost. It is nothing but instantaneous rate of change of total cost. So what they mean by it is nothing but dc by dx. Now, this is what they mean by it. So if I write it down, my dc by dx would be nothing but 0.005 into 3x square minus 0.02 into 2x plus 30. What I need to find is basically this value of dc by dx when x is equal to 3. So I will just substitute the value of x as 3. And if I do so, it becomes 0.005 into 3 into 3 square will become 9 minus 0.02 into 2 into 3 and then ultimately 30. Let us see what is the answer that we are getting. So if I take it down, so it is nothing but 27 into 5 into 10 raised to the power minus 3. This will become nothing but 6 into 2, 12 into 0.01 plus 30. So if I simplify, this becomes nothing but 7 into 5 is nothing but 35. 3 will come. 5 into 2 is 10. 10 plus 3 is 13. And then there are 3 decimal places I will have to write. This will become nothing but 0.12 plus 30. So let us take the sum of these two first. So this becomes nothing but 0.015 plus 30, and that comes out to be nothing but 30.015. So this is the answer that we are getting. You can check my calculation. By chance I have done something wrong, you can correct it, but the method remains same. Now in the earlier question, the question maker was kind enough to give us the expression. In this, they have not given us the expression. We'll have to write that expression. So in our algorithm, you can see the first part of generating the function that we need to find the rate of change of, that becomes an additional step. And after that, the differentiation part will remain same. And then from there, we'll get the rate answer. You can see that this part, now we'll have to do more in this question. So question says that the volume of a cube is increasing at the rate of 9 cubic centimeter. So what they are asking is V is the volume. The information that is given is dV by dt is equal to 9 cubic centimeter per second. And since the unit is given here, from here you can also understand it is not the volume, but the rate of change of volume with respect to time. Next thing, how fast is the surface area increasing? Now if you can see that the next what they're asking is how fast is the surface area increasing with respect to time when the value of the length of the side is nothing but 10 centimeter. So this is how I need to, this is what I need to find. With the third part, I can write down the strategy of solving the question. So what I can do is I can write the volume Now if I write the volume, it is nothing but x cube. So if I'm writing a dv by dt, it becomes nothing but thrice of x square dx by dt. This is first. So what I am planning to do is I am going to find the rate of change of volume. From there I will get the value of dx by dt. Now if I do ds by dt, let us see what is the common factor. So s is nothing but 6 times x square, because every surface will have area of x square. There are 6 surfaces to a cube. So answer becomes 6x square. So if I find the value of ds by dt, it is nothing but 6 into 2x into dx by dt. So you can see that the thing that I know the value of x, they have given in the question as nothing but 10. I do not know the value of dx by dt. If I somehow find this, I get my answer. So that I can find using my third step. So what I can do here is put the value of dv by dt, that is 9. This value is nothing but at x equal to 10. So this becomes 10 square into dx by dt. So let us find the value of dx by dt x equal to 10. Substitute the value in ds by dt and get the answer. So if I do so, this becomes nothing but 3 into 10 raised to the power minus 2 will be equal to dx by dt at x equal to 10. So in the next step, what I can do is I can substitute this value and get the value of ds by dt. So if I have to find this value, let us substitute. So this becomes 6 into 2 into 10. And this is nothing but 3 into 10 raised to the power minus 2. So what I'm getting is 6 into 3 is 18. 18 into 2 is nothing but 36. And then 10 raised to the power minus 1. And square centimeter per second. Units always you should keep in mind, because then you will lose 1 mark just for not writing the unit. So answer becomes 3.6 square centimeter per second. Now this is quite a simple question, again based on geometry. So again the same steps we are going to follow. Let us first write what they have given us. So they have given the value of dr by dt, that is nothing but radius of the circle is increasing at the uniform rate of 3 centimeter per second. So this is given to us. And now what they're asking is the value of area dA by dt, and when the value of the radius is equal to 2 centimeter. Now it is very simple. In the third step, we'll write the value of a. For a circle, it is nothing but pi r square. And if I write that, the value of dA by dt comes out to be nothing but pi into 2r into dr by dt. We have done the differentiation. Once we have done that, now all we need to do is substitute the relevant value. So if I do so, pi is pi. The value of r is given as 2. The value of dr by dt is given as 3. So you can see that the answer comes out to be nothing but 4 into 3, 12 pi. Do not forget to write the units. It is nothing but square centimeter per second. So it is very simple question. You just need to follow the simple steps of writing what is given to us, what we need to find. Then make the function, differentiate and find the rate of change. Now we can see that the next question talks about that the value of the side of a equilateral triangle. So first let us draw an equilateral triangle and figure out what is given to us. So if I draw an equilateral triangle like this, so what you'll understand here, what they are first giving us is basically, if I take this side as x, since it's equilateral, every side will also become x. And every angle will become nothing but 60 degree. So this is what is given to us, an equilateral triangle. Now another information that they are giving us is nothing but the value of dx by dt is nothing but 2 centimeter per second. This additional information is given to us. What they're asking in the next step is what is the value of dA by dt when the value of the side is nothing but 20 centimeter. Mind the units, because sometimes in unit also the whole game will be played. So this we have. Now what we are going to write is we are going to write the value of area. Now, if you want to find the area, there is a direct formula that you can remember. If you do not remember the formula, you can drop a perpendicular from the vertex to the base. So base is nothing but x. So we can write half of x into h, that is nothing but height. And in this triangle A, B, D, if you look into the height, that is nothing but h. What we can do is we can apply the value of sine theta. So for finding h, if you do not remember, only in that scenario, what we are saying is h by x is nothing but equal to sine 60 degree. 60 degree is nothing but root 3 by 2. So the value of a, h from here comes out to be nothing but x root 3 by 2. So if I put the value here, it becomes 1 by 2 into x into root 3 by 2 into x. So the value of area, and if this you should remember as a result as well, comes out to be nothing but root 3 by 4 x square. This is a very important result, area of an equilateral triangle. Now, if you have known this, we could have avoided all these steps. From here, we could have directly written this area and move on to our fourth step, that is implementation of the strategy. So we are going to differentiate dA by dt, and if I do so, it is root 3 by 4 into 2x into dx by dt. Now all the things are known. Root 3 by 4 is fine. The value of x that they have given is nothing but 20. And the value of dx by dt that is also given in the question is 2. So let us substitute all the values. So this 4 will get cancelled out. And what we are left with is nothing but 20 root 3. Do not forget the units, square centimeter per second. So it is a simple question, nothing very complicated. We need to write the proper steps in order to get full marks in this question. Now this 2023 question is a case study type of a question which has two parts. So you can see that they are talking about a roller coaster in the question. This roller coaster is given by this polynomial equation a times x plus 9 into x plus 1 into x minus 3. And you can see that it crosses, what they have saying is basically, if they talk about this roller coaster and if I draw the diagram, it is something like this. And what they're saying is this crosses the y-axis at a point 0 comma minus 1 like this. So what they want is the value of a and then the second derivative. So if you know the value of a, obviously the second derivative part will become very easy. So what we can do in this question is, first, for doing the first part, let us satisfy this point because this is on the curve. So if I put 0 in place of x, what they're saying is the value of f of 0 comes out to be minus 1. This is what they're saying. So if I put 0, this becomes minus 1. And if I put 0, it actually becomes a into 9 into 1 into minus 3. So the value of a from here comes out to be nothing but 1 by 27. So the first part is done. It is very simple. If I move to the second part, what they want us to do, once we have figured out this function fx as nothing but 1 by 27 into x plus 9 into x plus 1 into x minus 3. Once you have got this function, what I can do is basically simplify and then differentiate twice. If I simplify it, it is 1 by 27 times. It becomes nothing but x square plus 10x plus 9 into x minus 3. And if I simplify it once more, it is nothing but x cube plus 10x square plus 9x. And then minus 3x square minus 30x minus 27. And if I do so, it is nothing but 1 by 27 x cube plus 7x square minus. So once you figured out this function, what we can do is we can differentiate it twice. So if I differentiate it once, it is 1 by 27 3x square plus 14x minus 21. And if I differentiate one more time, I have double dash of x becomes nothing but 1 by 27 into 6x plus 14. Now we want this value at x equal to 1. So all we need to do is just put the value of x equal to 1 and see what is the answer that we are getting. So if I do so, it becomes nothing but 6 plus 14, that is nothing but 20. So answer becomes 20 by 27. So you can see that not a very difficult question. We need to just figure out the value of a, differentiate it twice and put the value of x equal to 1. Now this 2023 question is a case-based study question. It talks about a device that they have given or a tank that they have given in which the upper part is cylinder and the bottom part is cone. And what they're saying is they have filled only the conical part of the cone. So they have referred to this cylindrical part, but it is just a distraction. What they want to discuss is the conical part only. Okay, so this makes the question simpler. Otherwise, it could have, or it is a potential to become a very good question otherwise. So if I look into this, what they're saying is if I look into this conical part that is given to us, there is a tab below here. And there is an opening like this. So what they're saying is this part is full, initially at least. And now water is coming out of here. And then the water is coming out at a uniform rate. So what is happening is the volume of water getting out is nothing but minus, or the volume at which the volume of the water is reducing is nothing but minus 2 centimeter cube per second. Since it is reducing, I am putting a negative sign into it. So this is the first thing that is happening. So now another thing that we can observe from here is they have also given us that this semi-vertical angle or this angle is nothing but 45 degree. Another information. So these are the information that are given to us. Now the basic on which what they're asking is the volume of the water in the tank in terms of radius r. So if I take the radius r at a certain point here, let us say the radius is r. What I want to tell them is what is the volume of the water. So volume of the water has a direct formula because it is nothing but the volume of the cone. So volume of the cone can be written as nothing but 1 by 3 pi r square h. You can see that here r is fine but h is not given. But from this geometry, if this part is nothing but the h, we can write the value of 1045 degree. That is nothing but r by h. So from here you can see that r comes out to be equal to h only. So once we know this part, now this can be easily written as nothing but 1 by 3 pi r cube since h is equal to 1. The first part we have done. Now let us move to the next part. Next part what they're saying is find the rate of change of radius at an instant with r is equal to 2 root 2. Now if I take dv by dt, it will become 1 by 3 into pi into 3r square dr by dt. So now what they're asking is find the rate of change of radius at an instant. So what they're saying is this at r is equal to 2 root 2. This is also r is equal to. So this we need to find at r is equal to 2 root 2. So if I put all the values, this value was nothing but minus 2. This came out to be nothing but pi r square. R is nothing but 2 root 2. Let us substitute that. And dr by dt. So from here we can get our answer. So your dr by dt comes out to be nothing but minus 2 by 8 pi. And this is centimeter per second. Unit is very important. So answer comes out to be nothing but minus 1 by 4 pi. You can check my calculation in case I have gone somewhere wrong. This is the second part. Now let us move to the third part. In the third part, what they're asking is, what is the rate at which the wet surface area of the conical tank is decreasing? So what will happen is, as the water level will go down, whatever is the wet surface area, that will also go down. So what now we are talking about is nothing but the surface area of this curved part. So for that, we have a formula. So what for that I will consider this curved length as L. So if I take that in the third part, I will have to use the curved surface area. If I use the curved surface area, it is nothing but pi r L. You can see that at an instant in this diagram or in this triangle, when this is nothing but r, this is nothing but s, this will become L, and this angle is nothing but 45 degree. So if I apply a simple formula, I can connect r with L and write that as sine 45 degree would be nothing but r by L. So sine 45 is nothing but 1 by root 2 is equal to r by L. So the value of L becomes nothing but r. So if I take this value, I can write my this area that they are asking as nothing but pi r into root 2r. So it becomes pi into root 2r square. What we can do is we can differentiate it. So if I do dA by dt, it comes out to be pi root 2 into 2r dr by dt. Let us substitute the values and see what will happen. If I substitute the value, it is nothing but minus 1 by 4 pi. So it becomes 2 root 2 pi. This will also become 2 root 2 as it is given the question. And this is minus 1 by 4 pi. So if I put all of these values, let us see what do I get. So it becomes nothing but 8 pi. So pi and pi will get cancelled out. This will become 8 into minus 1 by 4. Comes out to be minus 2 square centimeter per second. Units are again very important. Now in the fourth part, what they're asking is when dv by dt is nothing but minus 2 cubic centimeter per second. Now what they're asking, at when h becomes 4, L becomes 4, the slant height is 4, at that point, what will be the value of dh by dt? So what we are going to do in this scenario specifically is, let us write the volume. So volume was nothing but 1 by 3 pi r square h. Now instead of replacing r, or instead of replacing h, let us replace r. So since we figured out that r was equal to h, in the same part we can write this as nothing but pi h cube And now if I find dv by dt, it comes out to be nothing but pi h square. So once you have got this value dh by dt, from here we can find all the relevant values. All we need to do is substitute the value, so this becomes minus 2. You can see only thing that we do not know is nothing but h. But if I draw a very small diagram here, where we know that this angle, if I draw the diagram, and it was something like this is L, this is H, and this is 45 degree. So if L becomes 4, I can apply nothing but cos of 45 degree, and this will be nothing but H by 4. So H comes out to be nothing but 4 cos 45 degree, that is nothing but 1 by root 2. So value of H comes out to be nothing but 2 root. Once you have got this value, you can substitute it here. So this becomes a 2 root 2 whole square dh by dt. And we can see that the value will come out to be the same as earlier. So dh by dt comes out to be nothing but minus 1 by 4 pi centimeter per second. Now in this type 2 problem, we are talking about increasing and decreasing function which are based on algebraic expression, these kind of problems. So only thing that you need to know in solving such questions is, if you have the value of f dash of x greater than or equal to 0, it means the function is increasing in nature. If you got the value of f dash of x is smaller than equal to 0, then the function is decreasing in nature. If sometimes question talks about strictly, if they use this word strictly. So strictly increasing would mean the condition will change slightly. We will write f dash of x is greater than 0. And if they say strictly decreasing, in that case, the condition will become f dash of x is smaller than 0. The equal to part will go away. So this is the only theory that we need to know for this. Now let us see what kind of question was asked in 2018. This question talks about a cubic polynomial that is given to you. And we need to talk about when it is strictly increasing. Now you can see that strictly word in the question, so you will have to not use that equal to sign. So if I do it, the a part becomes nothing but f dash of x we will find. It is nothing but minus of 6x square plus 18 minus 18x minus 2. See now, once we have done that, we got the derivative. In order to find strictly increasing, we are going to put it greater than 0. Now if you put this greater than 0, I have minus 6x square minus 18x minus 12 is greater than 0. Minus 6 can be taken common. So x square plus 3x plus 2 is greater than 0. And if I take negative number on the other side, the inequality sign will get flipped. This is very important. This is where most of the students will do it wrong. Now next step is to factorize this. So it is x plus 2 into x plus 1 is smaller than 0. But if I draw the wavy curve, one point would be minus 2, another point will be minus 1. So we are getting positive values here, then negative, then positive. If you want to draw the wavy curve, it is going to be like this. We do not need to include these values because they are talking about strictly increasing. Now wherever this condition follows, smaller than 0, so it will happen between minus 2 and 1. So minus 2 to minus 1, this interval is where the function is going to be increasing function. So this is how we get the answer for the first part. For doing the second part, I will have to put f dash of x is smaller than 0. And if I do, it will become minus 6x square minus 18x minus 12 is smaller than 0. When we solve it, ultimately it will reduce to the same expression, x plus 2 into x plus 1. Just the sign will be different. So when we are doing it, in this time from here, the values that we need to check or take is that is positive values. So here the answer becomes minus infinity to minus 2 union minus 1 to infinity. So what are the two steps in this question? First, find the derivative. This is nothing but the first step. And then the next step is to apply the method of intervals or the wavy curve method by putting in the condition. Now in this question, what they want is basically, they want us to show that this function is always increasing. So what should happen is ideally, if I find or write my two steps, that is finding the derivative first. What should happen is this derivative should always come out to be greater than equal to 0. If this happens, this condition will get proved. So there are two steps. First to find the derivative, then show that it is always positive. So in the first step, let us find the derivative. So if I find f dash of x, it is nothing but 3x square minus 6x plus 6. Second, now what will happen here is, if I take 3 common, it is nothing but x square minus 2x plus 1. So you can see that this becomes nothing but x minus 1 whole square. Now we know that a perfect square is always greater than equal to 0. So this value comes out to be greater than equal to 0. So in the third, we can say that since derivative came out to be greater than equal to 0, whatever value of x we put is unimportant. It is always going to be an increasing function. And here you can see that since strictly word is not being used, we can take this greater than equal to condition. Now again in this question, they are asking the similar kind of question. They want us to do in this 2023 question, check for it strictly. So what we are going to do is we are going to find the derivative. It comes out to be nothing but 6x square minus 3. Second part, since they are talking about strictly increasing, we'll put this greater than 0. So 6x square minus 3 is greater than 0. This is what we are getting. And now, if you factorize this comes out to be x square minus 1 by 2 is greater than 0. Now we can factorize this into x minus 1 by root 2, then x plus 1 by root 2. And now if I draw from the method of intervals, what will I get is there is one very important value minus 1 by root 2. There is another very important value 1 by root 2. So positive, negative, positive. Or we can also draw the wavy curve like this. Since it is strictly, we will not consider this point. So my answer becomes minus infinity to minus 1 by root 2. Union 1 by root 2 to infinity. Now we can see that in this question there is a bi-quadratic kind of a function that is given to us, but our steps remain same. We are going to first find the value of f dash of x. If I do that, this becomes nothing but, so one step we could have simplified and written this is x square into x minus 2 whole square. So we will apply our product rule to differentiate it. So d by dx of x square we will have to write, then x minus 2 whole square, then x square into d by dx of x minus 2 whole square. And if I do so, the first part becomes 2x into x minus 2 whole square. The second becomes x square into 2 into x minus 2. This is what we are getting. Now, what we can do is we can factorize it. So I can take this x and x minus 2 common. So what is remaining in the first part is x minus 2. What is remaining in the second part is nothing but x. So what am I getting is x into x minus 2 into 2x minus 2. I can take 2 common. So this becomes 4x into x minus 2 into x minus 1. This is what we are getting. Now once you have done that, the condition of an increasing function is nothing but f dash of x needs to be greater than or equal to, because they have not mentioned the word strictly. This is what we are going to get. We are going to put this 4x into x minus 1 into x minus 2 as greater than or equal to 0. Now if I draw the wavy curve, or from the method of cases, one point if I put this equal to 0 is x equal to 0. Another point if I put this equal to 0 is x equal to 1. From this we have x equal to 2. So from here I can draw a graph like this. Positive, negative, positive, negative. What we want is basically where it is positive or equal to 0. So my answer to this question becomes 0 to 1, where both the points are included. Union 2 to infinity, where 2 is also included. So this is the final answer to this question. So again, you can see the steps are largely the same. If I look into 2018 question, again a bi-quadratic question. Now also you can try this question. So if I look into this question, I am going to find the value of f dash of x. So it becomes nothing but 4x cubed by 4 minus 3x square minus 10x plus 24. We can solve it further, becomes 3x cubed into 3x square minus 10x plus 24. This is what we get. Now once we have got this, what we need to do is we need to simplify or factorize this, because if I want to either solve part 1 or part 2, I will have to solve this inequality. F dash of x is greater than 0 and then f dash of x is smaller than 0. So how to factorize a cubic expression, that will be an important part in order to apply the wavy curve method. So the method is, what we are going to do is we are going to take factors of 24, satisfy and check what is getting satisfied. So first let us take the value as x equal to 2 and see whether this is a factor or not. If I put x equal to 2, it becomes 8 minus 3 into 4 minus 10 into 2 plus 24. So what is happening is this is 8 plus 24. This becomes nothing but 32. Then this is 12 minus, so this also becomes 32. You can see that it gets satisfied. So what we can say is, see, x minus 2 is one of the factors. So once you have got this, the next part is we will take this expression, that is x cube minus 2x square minus 10x plus 24, and divide it by x minus 2. So if I take x square here, it becomes x cube minus 2x square minus plus And then if I subtract, this becomes 0. What I am getting is 10x plus 24. And then if I multiply 10 here, minus 10, it comes out to be nothing but, sorry, there was 3x square. Let us correct it. So this becomes nothing but minus x square minus 24. Now what we will do is we will take here minus 1 or minus x. So this becomes nothing but minus x square minus plus 2x. So if I write it down, it comes out to be nothing but minus 12x plus 24. So if I take minus 12 here, it will get divided and the answer becomes 0. So what we can see here is basically there are two parts, x minus 2, then x square minus x minus 12 greater than 0. And the second part can be further written as x minus 4 into x plus 3. So you have got all the three factors here. You can multiply and check it once, but based on whatever we have written, it comes out to be correct. Now, once we have done that, now we can draw a simple diagram based on method of cases to minus 3, 2, and 4. So this becomes plus minus plus minus. We can have open at all of these points. So what we are getting here is minus 3 to 2 union 4 to infinity. This is what we are getting. This is the answer to the first part. Now, when this is the answer to the first part, the second part is obviously whenever it is not increasing, it is going to be decreasing, strictly decreasing. So answer to this part becomes nothing but minus infinity to minus 3 union 2 to 4. You can also solve and check, but it is going to be the same thing. Wherever it is not increasing, it is going to be decreasing. So see, in this kind of question, you can see that there was this additional step of factorizing a cubic. And what is the logic behind that? We will take one of the factors of the constant term, check for it, get one factor, divide by that factor, make it a quadratic, get the other two factors. So this is the method that we are going to do. And after that, what we did earlier, the same thing we are again doing. Now, in this next question, you can see that the question remains same. It is just that the kind of function we have used, that is changing. So again, we are going to find the value of dy by dx as we do in all the questions of increasing, decreasing. So it becomes 2x e raised to the power minus x. We are using product rule. Then x square differentiation of e raised to the power minus x would be this. Now what we are saying is this is decreasing. So now decreasing would mean dy by dx is smaller than 0, equal to 0. Now they should have ideally used strictly decreasing. In that case, this will happen. So if I take this, it becomes nothing but twice of x e raised to the power minus x minus x square e raised to the power minus x is smaller than 0. And now it becomes 2x minus x square into e raised to the power minus x is smaller than 0. Now see, this part e raised to the power minus x is always positive, because exponential function, whatever you put in the power of e, it is never going to be a negative number. So what we can say is whatever answer we are going to get is from the other part only. Now what we can do is we can multiply with the minus sign. So it becomes x square minus 2x, and the sign will get flipped. This is important, don't forget this. In the next step, we will get our answer. So if I factorize this, it is x into x minus 2 is greater than 0. Now what they want is basically the simplification of this part. So I can solve using method of intervals, plus minus plus. And these points are not getting included. So when it is going to be positive is minus infinity to 0 union 2 to infinity. And this is going to be your answer. You can see that the D option matches the description. So it is our answer. Now this question involves using certain level of trigonometry to solve the question. So what you can do in this question is, we can take the function and differentiate it first, because that is always our first step. So this becomes nothing but cos x minus sin x. You need to write 2 or 3 more steps in the process of coming up with the differentiation part. I think you can do that. In this duration we are talking about. Now what they're saying is it is increasing. So in the second part, increasing would mean it needs to be greater than or equal to 0. So that would mean cos x minus sin x should be greater than or equal to 0. This we need to simplify and solve. Once you have got this, there are multiple ways to do it. One of the ways is I can do it using graph. So cos x should be greater than or equal to sin x. So if I draw both of these graphs, and this is, I think, some easiest method that you can get it out there. If you draw this graph, cos x graph we all know is something like this in 0 to 2 pi. And sin x graph, if I want to draw it, will start from here, go like this, and then go like this. So this is what is the graph. So you can see that what they want is cos x should be greater. So that means this first black curve should be above. So cos x is greater here, then again the cos x becomes greater in this duration. So whatever is the answer, that is going to become an answer. Now if you find this point of intersection, they are either equal at pi by 4 or at nothing but 5 pi by 4. So these are 2 points of intersection of the graph. So you can see our answer can be between 0 to pi by 4, then 5 pi by 4 to 2 pi. So answer to this question now can be directly written from here is 0 to pi by 4. Union 5 pi by 4 to 2 pi. Now what we are saying in the next part is this is for increasing. If I want to write the answer for the next part, that is f double dash of x is smaller than equal to 0, the decreasing part. Our answer from directly here, we can, wherever it is not increasing, it will be decreasing because the nature of the graphs will change. So answer becomes from 5 pi by 4 to 5 pi by 4. Endpoints will be again included. Now in this next question, again our steps remain largely the same. What we are going to do is we are going to find the value of f dash of x. It becomes a times sec square x plus cosec square x. If you look into this part, and then what is happening here is, if I want to find whether it is increasing or decreasing, I need to understand what is the sign of f dash of x. Now see, a they have already given is positive in the question here. And see, sec square x, because it is a perfect square, will be greater than 0. Cosec square x, since it is a perfect square, will be greater than 0. So when you add two positive quantities, you will get a positive quantity. So whole of this quantity is positive, the quantity before it is also positive. So what we can conclude is basically, based on this evidence, that this is going to be always greater than 0. So it becomes nothing but an increasing function. So very simple question. In just 2 or 3 steps, you can easily understand that. Now in this 2023 next question, the idea also remains same. We have given a function, similar kind of a concept. What they're asking is now other way around, it is strictly decreasing. That would mean I will have to find f dash of x first. That is a derivative of x is 1. Derivative of cos x is nothing but minus sin x. So if I write it down, it is a times 1 plus sin x. Now what they're saying in the next part is it is strictly decreasing. This would mean this should be smaller than 0. That would mean a into 1 plus sin x. This should be smaller than 0. Now we can understand from here one very commonsensical thing is sin x always lies between minus 1 and 1. This we already know. So if I add 1 on all the sides, so this will become 0. This will become 1 plus sin x. And this becomes nothing but 2. So the value of sin x, 1 plus sin x, will always lie between 0 and 2. So what we can understand is 1 plus sin x, if I take as a quantity, will always be greater than equal to 0. So what we can understand from here is the value of a, for this to be decreasing, should be nothing but smaller than 0, because this quantity is always greater than 0. So answer to this question becomes nothing but B part, that is nothing but 0 to infinity. Now this next question of 2023 talks about a function that is half trigonometric and the half is nothing but algebraic. So what we need to do is again the same 2 steps, find the derivative of fx. And if I do that, for the first part, I will have to use the quotient rule. So if I use my quotient rule, it is nothing but d by dx of 16 sin x minus into 4 plus cos x minus derivative of denominator, that is d by dx of 4 plus cos x, and into 16 sin x, divide by 4 plus cos x whole square. And then if you differentiate this x, it comes out to be minus 1. So this is what we are getting as the expression of derivative. Now we will have to do some calculation, and if I do so, the first part becomes 16 times cos x into 4 plus cos x. The second expression becomes nothing but minus sin x into 16 sin x. And if I take LCM, then this part will also come out to be nothing but 4 plus cos x whole square. And the denominator becomes nothing but 4 plus cos x whole square. So this is what we are getting. If I simplify, and for that I will have to take this 16 common from here. So it comes out to be nothing but 16 times. In fact, it will make sense not to take common. So if I multiply this, this is nothing but 64 cos x plus 16 cos square x. The second term becomes nothing but 16 times sine square x. And if I open the bracket that I have, it comes out to be nothing but 16 minus cos square x minus nothing but 2 into 4, 8 times cos x. And divide by nothing but 4 plus cos x whole square. So you can see that the denominator is already taken care of. We just need to take care of the numerator part. Now this 16 sine square x plus 16 cos square x, if I take this part, it comes out to be nothing but 1. So 16 will become 16. And now this 16, and then you have this minus 16, this will get cancelled out. We have, what we have remaining is nothing but minus of cos square x. And then 8 cos x, 16, if I subtract, it becomes nothing but plus 56 cos x. And in the denominator, we have 4 plus cos x whole square. If I again check this out, it comes out to be nothing but cos x or minus cos x I can take common. And if I do so, what I'm left is nothing but 56 minus cos x. Divide by 4 plus cos x whole square. Now let us go back to the question and check. What they're talking about, we are putting values between pi by 2 and pi. That would mean second quadrant. Now what will happen? So you can see that this part is positive because cos x lies between minus 1 and 1. And if I put a value in that, and if I add 56 on both the sides, this will become 55. This will become 56 minus cos x. So you can see that if I take this expression, it will lie between 55 and 57. So this is positive, there is no problem. If I look into the denominator, it is a whole square, it is also positive. So the sign of this expression would be decided by nothing but this cos x part. So I need to focus on this cos x. And now what they're saying is, we are putting values in this. Now that lies in second quadrant. So in second quadrant, cos x will become negative. So what is happening is, in the second quadrant, in the second step, we can see that f dash of x would be smaller than or equal to 0. Hence, this becomes a decreasing function. Now, next problem category is nothing but maxima and minima based questions on algebraic expressions. So you can see that this 2021 question, they have given us an expression of fx is equal to 4x minus 1 by 2x square. We need to find its absolute maximum minimum in this interval. So what the maxima minima usually are of two types. So maxima minima can be categorized into two categories. One of them is known as local maxima, local minima. And the another one is known as nothing but global maxima minima. There are these two categories. If I look into this first one, what is the method to figure this out? So what we are going to do is we are going to find f dash of x. And now after finding this, there are two ways to move forward. One, we can draw a wavy curve and understand from method of sign how it is behaving. So if it is moving from, so let us say that it is a minima like this. So what can happen is the slope will move from negative. So you can see that here it is a negative slope at this point, and here there is a positive. So if the slope is moving from negative to positive, it is point of local minima. But if the slope moves in the other direction, like if it is like this, you can see that it moves from positive slope to negative slope. So if this movement happens, then we'll call this as nothing but local maxima. Whenever derivative is difficult or second derivative do not exist, we are going to use this method. Sometimes there is another method that we are, most of the time this method we are going to use. So put f dash of x equal to 0. And then this is second method. So if I do this, after this, I am going to find the root of this. Let us say that x1, x2 are the roots. The next step would be after this to find second derivative and check the value of x1. Let us say that this comes out to be greater than 0. It will become opposite. That is nothing but local minima. And if it comes out to be, and let us say that the second one comes out to be negative, we are going to call this as local maxima. It behaves in the opposite manner. There are two different techniques. The first one is known as first derivative test. The second one is known as second derivative test. Both the tests are valid and can be used. It's very simple. Find derivative, check signs in the first case. Find derivative, figure out the roots, find second derivative, then check signs. It is nothing but second derivative test. Now, what is the difference between this concept and local and global maxima minima? Now, see, global maxima minima talks of a different thing. They are not talking about minimum or maximum values in the neighborhood. They are talking about in an interval, what is the maximum or minimum value. So, if the question talks like in this case, what is the absolute maximum value? So, they are not talking about what is happening in the neighborhood, like which is the minimum point in a neighborhood. No, they're talking about generally in an interval, what is happening, that we need to figure out. So, the technique is very simple. First, we are going to, in an interval, let us say a comma b is given to us. So what we will do is we will find local maxima, local minima. So like let us say that f of x1, what we did was basically, so the steps are very simple. In the first step, we will find derivative, put it equal to 0. Figure out the roots. Let us say that x1 and x2 are the roots. Then, in the second step, what we are going to do is we are going to find the value of function at a. We are going to find the value of function at b, then x1, then x2. Whatever is the minimum value that we are getting becomes global minima. Whatever is the maximum value that we are getting, that becomes global maxima. This is a very simple thing that we can do in such kind of questions. Let us see in this question how to handle this situation. So when they are saying absolute maximum value, they do not ask us, they are not asking us local maxima. What they are asking us is the global minima. So this word is corresponding to nothing but global maxima. This is what they are asking us. So what we are going to do, the first step is to find the derivative. I will find f dash of x, and this will come out to be 4 minus x. Next step would be to put this equal to 0. If I do that, the value of x comes out to be 4. Second thing that we are going to do is find the value of the function at the endpoint. So one of the endpoints is minus 2. If I put minus 2, it becomes minus 8 minus 1 by 2 into 4. So what we are getting is nothing but minus 8, and then we are getting minus 2. It becomes nothing but minus 10. So this is the value that we are getting. Next, we are going to find the value at nothing but 9 by 2. Let us see what happens at 9 by 2. So if I put 9 by 2, this becomes 4 into 9 by 2 minus 1 by 2 into 9 by 2 whole square. And if I simplify, it comes out to be nothing but 18 minus 81 by 4 into 2, 8. And if I simplify, it is 8 into 8, 64, 6, 8 times 1 plus 6, 14, minus 81 by 8. And if I further simplify, this is 3, 63 by 8. This is the value that we are getting at 9 by 2. Now let us also check the value of function at 4. So if I put 4, it is nothing but 4 into 4, it is nothing but 16 minus 1 by 2 into 4 square. So it becomes 16 minus 8. This comes out to be 8. You can see that the maximum value that we are getting is at what point? This is obviously not the maximum value. This value, if I divide 8 into 8, it's 64. So this is slightly less than 8. So what is the minimum value? The minimum value is nothing, maximum value is nothing but this value, that is nothing but 8. We have just taken derivative, put it equal to 0, figure out the roots of that equation. Then put the values in the function at the endpoints and those points that we have got new, and check what is the maximum and minimum value. Whatever is the maximum value, that is going to become the absolute maximum value in that duration. Now in this question, it is different. They are talking about local maximum and local minimum values. This is what they are asking us. So this we will have to follow the first approach. So the approach is very simple. We will find the derivative. It comes out to be nothing but cos x plus sin x. And they want us to check only between 0 and 2 pi. This is the first part. In the next step, we are going to put this equal to 0. So you can see that cos x plus sin x is equal to 0. And you can see from here that what we are getting is cos x is equal to minus sin x. Or we can write tan x is equal to minus 1. So there are two values corresponding to this for x. One is nothing but x equal to 3 pi by 4. That is in second quadrant. And another value will be nothing in the fourth quadrant. So 2 pi minus pi by 4. That is nothing but 7 pi by 4. These are the two values that we are going to consider. Now, once we have got these two values, the next step is to find the second derivative. Third step. So now if I differentiate one more time, my derivative becomes minus sin x plus cos x. This is what I'm getting. Now what I can do here is, I can check the value of the second derivative at both of these points. If I check them at 3 pi by 4, this becomes minus sine 3 pi by 4 plus cos 3 pi by 4. And if I check this value, sine 3 pi by 4 is nothing but minus 1 by root 2. Cos 3 by 4 is nothing but minus 1 by root 2 in the second quadrant. So you can see that the answer is minus 2 by root 2. It is smaller than 0. And hence 3 by 4 is nothing but the point of local maxima. Opposite. If it is smaller than 0, maxima, and vice versa. Next part, what we can do is nothing but we can put the value of the other part. That is nothing but 7 pi by 4. When I put 7 pi by 4, this becomes minus sine 7 pi by 4 plus cos 7 pi by 4. So what happens is this value also will come out to be negative. So this becomes nothing but plus 1 by root 2. And this becomes nothing but also again the same value, minus 1 by root 2. So this comes out to be 0. Now since this point is coming out to be 0, it is neither point of local maxima nor point of local minima. What will happen to this point, we'll see later on. But this is what it is. So what if I try and figure out what is the point of local maxima, it is nothing but 3 pi by 4. And that is the only point that we are getting in the duration of 0 to 2 pi. Next problem that we are going to deal with is nothing but maxima and minima based geometrical questions. Now most of these questions target the idea of nothing but global maxima and global minima. So this is what we need to find in most of these cases. That is the reason. What are the steps that we are going to follow? A geometrical conceptualization would be given to us. Out of that, we'll figure out a function that needs to be maximized or minimized. Then we are going to find its global maxima and global minima. This is what we are going to do. Now in this global maxima minima, we have already seen that there are steps. We put this equal to 0. Then after that, we find the values of f of a, f of b, that is the duration, and f of x1 and f of x2, and figure out whatever is the maximum or minimum value as the case might be. This is the process that we are generally going to follow in all such questions. Now, if I look into this 2017 question, it talks about a cuboid with a square base. So let us draw it. So this is a square and a cuboid. So the height is different, but in the base, the dimensions are same. So this is how it looks like. So this is nothing but x, this is also x, plus this dimension is y. This is what they're talking about. Also, they are saying that of a given volume. So that means the volume is given to us as v. So v is also given to us, and v will become nothing but x square y in this case. In the second part, what they're asking is the surface area of this closed cuboid with a square base is minimum. So surface area we need to write. So first surface would be x square and the base will also be x square. Now if I look into this surface, it would be nothing but x into y area. And then the one in front of it would also be x into y, that we can write. Now if I write this one, this surface will also be x into y. And the front of it will also be x into y. So this is nothing but the surface area. So if I write it down, it is nothing but 2x square plus 4xy. This is our s. Now what we need to do is we need to minimize this function. Now in order to minimize, we need to have it in one variable. Here we have got two variables, and this will happen in most of such questions. So what we need to do is we need to remove this y from here. And somehow if I can remove this y from here using this relation, then we will get an equation or an expression in one variable that we can differentiate and get to the answer. If I take the value of y from here and substitute, it is nothing but v by x square. If I substitute, s comes out to be nothing but 2x square plus 4x into v by x square. After simplification, the value of x comes out to be 2x square plus 4v by x. Now after that, it is a question of global maxima, global minima. So what we are going to do in the third part is nothing but we are going to find ds by dt, ds by dx. And if I do so, it comes out to be nothing but 4x minus 4v by x square. So if I put this equal to 0, what am I going to get from here is nothing but x 4x minus 4v by x square is equal to 0. So the value of v comes out to be nothing but x cube. This is what we are getting. Now, in order to understand whether this is a point of local maxima or minima, now we can do one more step. We can do one more derivative. If I take the second derivative of the same thing, what I get is 4 plus 8v by x cube. If I put the value of v here as x cube, the value of this comes out to be 4 plus 8, that is nothing but 12. And since this is a positive quantity, this value of v that we are getting from here, or the x that we are getting from here, this is nothing a point of local minima. See, it is very important to show this, otherwise you will lose 1 or 2 marks in the exam. So this part, it looks out to be something very obvious, but needs to be always checked in such questions, otherwise you will not get marks. If I move to the fourth step of the question, now it is very simple that it is happening when the value of x cube becomes equal to v. Now v that we figured out was nothing but x square y. So if you simplify, the value of y comes out to be equal to x. What has happened is two faces were already square. Two faces were already square. The third dimension that we're talking about now has also come out to be equal to x. So in this process, this cuboid has now become a cube. And this is what they wanted us to prove. You can see that there are 4 parts of the question. First part, you will write whatever is given in terms of geometry. Second part, you will write the expression and reduce it into one variable. In the third part, we will find global maxima, global minima. If I look into this next question of 2016, it talks about the least parameter of an isosceles triangle in which the circle of radius r can be inscribed. So what they are talking is, there is a triangle ABC like we have drawn here, and there is a circle inside this triangle touching all the 3 sides. Let us say that it touches at D, E and F, these 3 points. The radius of this circle that is inside is given as r. I have put it here. If this center is nothing but I, then what we can observe here is, if I look into this side that is BD, this will be equal to nothing but BR. And since I'm assuming here it is isosceles, then angle B will be equal to angle C. Also, AB will be equal to nothing but AC. So these are the things that are given in the question. So this is something that was given in the question. So if I assume this angle as nothing but theta, so what we have is angle A plus angle B plus angle C will be equal to pi. Both of these angles B and C are nothing but theta. So you can see that angle A will be equal to pi minus 2 theta. This is one thing that we can again very simply figure out. Once we have this information with us in the first step, let us move towards step 2. So if I find this, if I take this triangle I, B and D, see, we understand that this in center, if I join with the vertex, this becomes nothing but angle bisector. So if this whole angle is theta, half of it will become theta by 2. And this is perpendicular distance because we are joining center to the point of tangency. So this becomes nothing but. So this becomes a right angle triangle that we can very simply analyze. So once I have had this, I can find VD by applying tan theta by 2. So tan theta would be nothing but R by BD. And let us, for the sake of simplification, consider this as X. So it is nothing but R by X, or X becomes nothing but R cot theta by 2. Now this is very important because if this is X, from basic congruence you can also observe that this will also be X. And since both the angles are equal, this will also become X. And this will also become X. So if I draw this triangle that I have given here, that is IAE. If I take this triangle, let us see what happens. So if I consider this triangle, what you will observe is this point is E, this is I, this is A. This will be half of angle A. So this will become pi by 2 minus theta. This angle is 90 degree and this distance is also nothing but R. We have considered this is Y. So again we can write tan of this angle pi by 2 minus theta would be nothing but R by Y. So this becomes cot theta is equal to r by y, or from here we can find the value of y, that is nothing but r tan theta. Now once you have figured this out, now let us go to the question. The question says that the parameter of the circle. So if I take the parameter as p, it is nothing but sum of all the sides. And if I see the sides, it is nothing but AB plus BC plus CA. Now AB from here can be written as nothing but y plus x. BC can be written as nothing but x plus x. And CA can be written as nothing but x plus y. So we can see from here that our parameter or the value of the parameter comes out to be 4x plus 2y. And now here also we can substitute the value of x and y. If I substitute the value of x, it is nothing but r cot theta by 2, and the value of y is nothing but r tan theta. So if I differentiate this with respect to theta, let us see what do I get. So if I do that, this becomes 4r minus cosec square theta by 2 into 1 by 2. And the next part becomes nothing but 2r sec square theta. These are the values that we are getting. Now, if I want to find the least value, the question says that find the least parameter. So for the derivative will be equal to 0. So let us put this equal to 0. So if I simplify, what am I getting? I am getting 2r cosec square theta by 2. This will be equal to 2r sec square theta. And if I rearrange the terms, what I am getting is nothing but sine square theta by 2 is equal to nothing but cos square theta. Now, in order to find the value of theta, we'll have to solve this equation and get to an answer. Now, there is a simple way to do that. We can multiply by 2. And if I do so, this is 2 sine square theta can be written as nothing but 1 minus cos theta. And this is 2 cos square theta. So we have got a quadratic equation cos theta that can be written as nothing but 2 cos square theta plus cos theta minus 1 equal to 0. Now this is quite simple to solve. So if I solve this quadratic, the value of cos theta comes out to be minus 1 plus minus root of b square minus 4a and c by 2a. And if I take the positive sign, it becomes minus 1 plus 3 by 4. That comes out to 1 by 2. So what you are observing here is this extreme value in the fourth part. This extreme value that we are getting is coming at nothing but theta is equal to pi by 3. So if you put this value of theta is equal to pi by 3 in this parameter, let us see what is the value that we are getting. So this becomes nothing but 4r cot of pi by 6 plus 2r tan pi by 3. If I simplify this, this becomes nothing but cos of pi by 6 is nothing but 4r root 3. And this becomes 2r root 3. So answer becomes nothing but 6r. And this is how we get solution of this question. Now this 2016 is again a very interesting question. This talks about sum of length. What they're saying is, if I take a triangle ABC, the side opposite to angle A is small a, the side opposite to C is small c, then side opposite to B is nothing but small b. So what they're saying is, the sum of lengths of hypotenuse and the side of right angle triangle is given as nothing but constant. If I assume S as nothing but B plus A, what they're saying is the value of S is nothing but constant. This is given as constant. This is the first thing that they have given in the question. What they're saying is show that the area of the triangle is maximum. Now what they're asking is area of the triangle. If I write area of the triangle, it is nothing but half of base into height. So this is what we are getting from here. And then they're asking about the angle between these two things that were given, that is nothing but A. So it is slightly better if I could have taken this value as C. So this is the angle that they will ultimately want us to find, that is nothing but the value of theta. See, once we do this, now what we need to do is we need to put or convert this area in terms of only one variable, only then we will be able to differentiate. So in order to do that, let us write what conditions do we have. So if I write One is basically Pythagoras theorem. So if I write a square plus c square, it will be equal to b square. So if I take c square on the other side, it's nothing but b square minus c square. Can be written as b minus c into b plus c. If I substitute the value of b plus c, it is nothing but s. And in b minus c, I can again substitute the value of b from here. So it becomes nothing but s minus c. So this becomes s minus 2c. So the value of a square is nothing but root of s square minus 2sc. This is what we are getting. So now if I write the expression of the area, it is half of c into root of s square minus 2sc. This is what we are getting. Now see, you can see that s is a constant, c is the only thing that is changing. So in the next step or the third step, we can differentiate this expression with respect to c. And if we do so, it is nothing but half of root of s square minus 2sc. And then the next term would be nothing but half of c. And if I differentiate this, it becomes 1 by 2 root s square minus sc 2sc. And the differentiation of this becomes nothing but minus 2s. This is what we are getting. Now for this to maximize or minimize, the value of dA by dc should be equal to 0. If I simplify this, what will I get? I can take this 1 by 2 common. And if I take LCM, this becomes s square minus 2c. If I simplify this part, 2 will get cancelled out. What I'm getting is nothing but minus c divide by nothing but sc. Yes. Divide by nothing but a root of s square minus 2sc. This will be equal to 0. So you can see that s square minus 3sc will be equal to 0. The value of s comes out to be nothing but 3c. This is what we are getting. See, now let us understand what is happening. Let us try and interpret this answer. So let us again go back to the same triangle. So now what we know is basically s is nothing but equal to 3c. So 3c will be equal to nothing but b plus c. So what we are getting is twice of c is equal to b. Or we can write c by b is equal to 1 by 2. Now from this triangle that we had, if I write the value of c by b, it is nothing but cos theta. So the value of cos theta comes out to be 1 by 2. Value corresponding to that comes out to be pi by 3. So what they were asking us, that answer we have found, the angle between the sum of the length and a side. So this side was nothing but c, the hypotenuse was nothing but b. So this angle they were asking, we have figured that out. This 2020 question talks about a cone that is given to us. The height of the cone can be assumed as small h. The radius of the base can be assumed as small r. Now what they're saying is, inside this cone we need to put a cylinder in such a manner that it fits. Another thing is, I've assumed the height of the cylinder to be capital H and the radius to be capital R. So now this angle I have also assumed as theta, that is the angle that the curved surface makes with the base. Now what they're saying is, what can be the, or at what value of height of the cylinder will the volume of the cylinder that is inside this cone will be maximum. And they want us to confirm whether this height is 1/3 of the height of the cone. Now this is what the question talks about, and then they also talk about the volume. Once you get the height, obviously you will get the volume. So now let us try and first write what we want to find. So what we want to maximize here in this case is nothing but the volume of the cylinder. It is nothing but pi r square h. So here, since we have taken capital R, let us put r square and capital H. This is what we want to maximize. Now you can see that if I want to maximize it, there are two things that are changing, r and h both. So we need to eliminate one of those variables. And this is a common thing that we have been following in all such word problems. So what I need to replace is nothing but, you can replace h or r both. Now how to replace that? For that we will have to form some kind of a relation between r and h. Now if you look into this triangle that is given to us, one triangle that you can observe from this diagram is nothing but A, B and C. And if I write tan theta here, it would be nothing but h by r. And also we have nothing but triangle ADE. If I look into this, the same tan theta can be written as nothing but the height, that is nothing but AD, by base, that is nothing but DE. So you can see that the height would be nothing but the height of cone minus height of cylinder, and the base would nothing but be capital R. So once you have got this, using both of these relations, we can equate the value of tan theta. So h by r will be equal to small h minus h by capital R. So from here, if I find the value of h and substitute in the v, I will be able to get a function of volume only in terms of radius, and then I can differentiate and get the answer. So let us see how it works out. So if I write this, it is h r by small r will be equal to h minus s. The value of h that we are getting is nothing but h minus hr by r. And also we need to comment on this, so it is better to find this. So let us substitute from here. So if I substitute in the third step, my function of volume comes out to be pi r square into h minus h r by r. So if I simplify, it is pi h r square minus pi h r cube by small r. This is the function that we have got for v. So now our process is very simple. I will differentiate this with respect to the only variable that we have got, that is nothing but capital R. So if I do it, this is 2 pi h r minus 3 pi h r square by small r. These are the values that we are getting. Now what we will do in the next step is we'll put this or equate this to 0. And if I do so, what will happen is 2 pi h r will be equal to 3 pi h r square by r. So the value of r that we are getting after solving is nothing but 2 by 3r. This is the value that we are getting. Now since I want to find the value of h, let us put it in this expression that we have got earlier. The value of h comes out to be, capital H comes out to be nothing but h minus h into 2 by 3r by r. R and r gets cancelled out. And what we have got is nothing but h by 3. So the first result that they wanted us to prove, we have already proved. Now corresponding to this, the next result that want us to prove is it is 4 by 9 times the volume of cone. Now we can understand the value of h is nothing, and the value of r that we already found earlier was nothing but 2r by 3. So from here, now if I want to find the volume of cylinder, it is nothing but pi r square h. This is my fourth step. Pi r square h. So pi r is nothing but 2 by 3 r, and h is nothing but h by 3. So if I consider this value, what am I getting from here is nothing but 4 by 27 pi r square h. If I write the volume of cylinder, let us say that it is Vc, it will come out to be 1 by 3 pi r square h. So now what they're saying here is basically, we want to, is 4 by times the volume of cone. So if I divide V by Vc, what will happen is 4 by 27 pi r square h divided by 1 by 3 pi r square h. Everything will get cancelled out, one will be left with 1 by 9. So you can see that volume of cylinder is nothing but 1 by 9 the volume of cone. So we have proved both the results. Now here you should understand this algorithm very clearly, that what we are doing, first we need to understand or write a function in terms of only one variable. For this you will have to form multiple relations, do some elimination. Once you have got this, then you will differentiate this v, and then you will put it equal to 0. From here we will get our answer. There are two simple steps. Reducing variable in terms of one variable is very, very important. Now this 2019 question talks about a tank that is open at the top. The dimensions are given like I have shown in the diagram. The height of the tank is 2 meters. The width of the tank, I have assumed it to be x, and another dimension I have assumed to be y. These are the dimensions of the tank. Now what they are saying is, in how should we construct this tank so that the cost of construction is least. Now, cost of construction depends upon the surface area of this tank. And then there are different costs they have given. What they have given is basically, if I construct the base of the tank, it costs 70 rupees per square meter. And if I construct the sides, it requires 45 square meter, 45 rupees per square meter. And so there are variable costs. So now let us first write the area of the base. So if I write the area of the base from this diagram, you can see that it is nothing but x into y. So this is area of base. Now if I write the area of sides, so you can see that one side would be consisting of 2 and y. This side we are talking about. So area of this would be nothing but 2 into y, and there are two such, one and one that is just in front of it, this side. So there are two such. And similarly, we can have this front one also. So if I take this front one, this side can now be written as nothing but 2 into x, and then this is also, one will be in front of it. So 2. So now if I write that of area of sides, it comes out to be nothing but 4 times x plus y. This is what we are getting. Now once you have got this, what will be the area or the cost of base construction? If I consider this, I will have to multiply this 70 with this area, so 70xy. If I want to find the cost of site construction, the answer here would be nothing but 4x plus y, and the construction cost was nothing but 45. So answer that we are getting here is nothing but 180 times x plus y. So if I write a function of total cost, now this was my first part, drawing the diagram, second this. So if I write the total cost in the third step, C can be written as nothing but 17xy plus 180x plus y. Now here if you closely observe, there are two variables, x and y both. So our next step should be to reduce it in terms of only one variable. For that they have given one more relation, that the volume is nothing but 8 cubic meter. So if I write the volume, it is nothing but 2xy, this comes out to be 8. And from here, if I substitute the value of y, it would be nothing but 4 by x. So if I substitute this value in the first function, this will become 17 into x into 4 by x. And next, if I substitute the value in the next part, it is 180x plus 4 by x. Now once you have done this, we have got the function. The x will get cancelled out. In the first part, we are getting 4 into 7, 280 plus 180 x plus 4 by x. This is the function that we have got. So next step, or the fourth step, would be to differentiate it with respect to x. And if I do so, the first part becomes 0, the second becomes 180. Differentiation of x becomes 1, so 1 minus 4 by x square, and obviously we'll equate it to 0. And if I equate it to 0, 1 minus 4 by x square becomes 0, or the value of x comes out to be 2. Once the value of x comes out to be 2, the value of y will also become 2. Now we have got all the values. We can substitute and find the minimum costing that would be there. So this becomes 180 plus 180 into 2 plus 2. So answer becomes 180 plus 180 into 4. So this becomes 180, 4 into added 32, 3, 4, 1, 720. And if I add this up, it becomes 0, 0, 1000. The answer to this question comes out to be 1000 rupees. You can check the calculation, but we are going to follow this method to solve this question. And you can see that this method has been the same for the last 3 to 4 questions. Now in 2023, this case study based question was asked. This question talks about a tank that needs to be constructed. The dimensions of the tank are given like the base is a square base, and the dimensions are nothing but x and x, and the height is given as h. Now there are two things that are happening. One is basically there are two variables. One that they have given is nothing but the volume of this is given. So if I put x square into h, this is given as 250. Another thing that they have given is basically the cost of the land. So now there are two things that might contribute to costing of this tank. One is the piece of land that you're buying, and that is nothing but 5,000 per square meter. This is the cost of the land. So there are two costing elements. One is this cost of the land they are talking about. That costs nothing but 5,000 rupees per square meter. This is, and another costing that they're talking about in this question is nothing but the cost of digging. So if you are making a tank, you will have to dig and take that earth out. So that was given as nothing but rupees 40,000. That cost of digging is 40,000 h square. So these are the two things that are given in the question. Yes. Now there are multiple parts in this question. First talks about find the cost function in terms of x. Now let us write it down. So if I want to write costing, there are two costs. One is cost of land. Now this is my first part. And the second element would be nothing but cost of digging. There are two things into it. Now cost of land would be nothing but whatever is the price of per square meter, that is 5,000 into area. So area will be nothing but x square. This is the cost of land. If I want to find the cost of digging, and it will depend on nothing but the height, and that is given as nothing but 40,000 into h square. You can see that there are two variables involved, x and h. What they want is only one variable. So in the next part, what we want to do is reduce one of these variables here. So you can see that there is one more relation of volume that is given to us. So the volume of this is given as nothing but 250. So we have this relationship between x square and h. So from here, we can put the value of h. So what we are getting is 5,000 x square. This is 40,000. And h, if you put it, is nothing but 250 by x square raised to the power 2. So if I simplify this, I should get a function in terms of x that comes out to be 5,000 x square. This will become 4 into 10 raised to the power 4. This becomes 25 square into 10 square by x raised to the power 4. And if I simplify it further, it is 5,000 x square plus. We can write this 25 as nothing but 25 into 4 into 25, and then we have 10 raised to the power 6 by x raised to the power 4. If I simplify it further, it becomes 5,000 x square plus. This will also become 100. So we have 25 into 10 raised to the power 8 by x raised to the power 4. So we have got the costing function in terms of only one variable, that is x. Once you have got it, the next part of the question says that find the value of dc by dx. So second part, let us do that. So if I find dc by dx, it comes out to be nothing but 500 into 2x minus 25 into 10 raised to the power 8 into minus 4 by x raised to the power 5. So this is the basic derivative that we have figured out. Now if I simplify this, this comes out to be nothing but 10,000 or 10 raised to the power 4x. Here there will be nothing but a minus sign, and this becomes nothing but 25 into 4 will become again 100. So this becomes 10 raised to the power 10 by x raised to the power 5. This is what we are getting. Now, in the next part, what they're saying is basically find the cost that is minimum. So we will have to put in the third step this dc by dx equal to 0. And if I do so, it is 10 raised to the power 4x minus 10 raised to the power by x raised to the power 5 equal to 0. So what we are getting from here is x raised to the power 6 is equal to 10 raised to the power 6. So the value of x comes out to be 10. And this is we have figured out. Now in the next part of the question, and this is the B part of the same, they're asking, check whether the function cx expression is increasing or not. Obviously it is not increasing because it is becoming 0 at a point. And after that the values will change. So obviously this is not an increasing function. B part, if you want to answer, it is not an increasing function. So again, a case-based study. But what they have done is basically by giving this cases or different questions in this, they have actually made this solution simpler because they have given you the steps that you need to actually follow to get to an answer. So using all these previous year questions, I have concluded all the important concepts and problem solving techniques that are required to excel in board exams. I hope you liked it. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.